Good morning, everybody. I thought today I would talk about Devcontainers and how they work. So, have you ever been looking at a GitHub repository and you're like, wow, this looks great, but I don't know. It seems like a lot of dependencies I have to install. Maybe you look at their makefile and you're like, oh my god, at least they have a makefile, that's nice. This makefile is used modular though. What does their makefile actually do? So then maybe you look at their makefiles, and you go, okay, dependencies.make, and you go, okay, what do I need to do? Oh my god, it installs all these submodules, and now I have to have Go installed. Ridiculous. Protocol generator, no. I don't want any of that. And poetry, what? I have to have poetry. Oh yeah, because there's a Python project in here. Well, do I have a solution for you? So I'm going to show you a quick demo. So, JetBrains makes a thing called Gateway. It's also in any other JetBrains product like Intellij IDEA, but Gateway is, I've found to be the easier way to do this. You click Devcontainers, and I have a remote Docker host set up. So right now I'm on my laptop, but I have devbox.remote, which is literally sitting not even a foot away from me on my desk. It is Alienware Aurora R13. I'm using it via Tailscale, so if I go up here, go to Tailscale, network devices, these are my devices. I have DevBox and Net, and then other devices on the Tailscale network. If you don't know what Tailscale is, it's essentially like managed WireGuard. So anyway, without further ado, we're going to hit new dev container, and devbox.remote has already been selected. We notice that it asks you for a Git repository URL, or you could do from local project if you wanted to locally clone a project that already had dev containers set up, but we're going to do it from a Git repository URL. So all we have to do is go over here, go copy the SSH clone URL, pop that bad boy in there, and it will specify the branch that you want. I have two branches. I'm going to go for main, and I'm going to build container and continue. It is going to build the container, which involves quite literally just pulling the container down because I have it pre-built, and we'll talk about that in a minute. And then once it builds and pulls, it will extract, and it will do some special sauce where it takes your container dependencies and mounts its own dependencies inside of your container, and then gives you the option to run it. So I think that's pretty cool. JetBrains does things a little bit differently than the VS Code implementation, which I find confusing at first. See, like it's adding JetBrains dev container features as a volume mount, which I looked at that at first and I was like, why are you doing this? But then I realized why they do this, and it makes a lot of sense. But it essentially makes a new Docker container from your dev container that you already spent time making. I have an entry point script, so my entry point script does something fun. It automatically resolves your GitHub username via SSHing into GitHub with your SSH auth socket. In order for this to work, you have to have SSH forwarding installed, so I essentially use your SSH key to SSH into GitHub, and I rip your username, and then I configure Git with your username, so you don't have to do that manually. Then I set your path, set your shell. We have Z shell, and notice how entirely pimped out your Z shell is once this loads. And we have a way to get all of our tooling and all of the dev dependencies up and running without having to install anything besides just literally running this container. There's like zero mental workload involved in copying and pasting a link and hitting run. I think this could really benefit a lot of projects just out in the open, and a lot of projects at the company, because similar benefits to Nix without a lot of learning curve. You just write a Docker file that has all of your dependencies set up, and other people can then go and use said Docker file, and it just works. So here we have our dev container has been created. Give it a second. It's going to open, and it opens. Notice it's not the default Intellij IntelliJ, it's actually my IntelliJ, like my customized IntelliJ. I had to do zero work to get that to happen. It just literally decided, okay, so you're going to use IntelliJ 24.2.2 EAP version, and you have these plugins installed, so we're just going to install that for you. So I have IdeaVim installed, I have GitHub Copilot installed. Of course, I have to log into GitHub for a new session, but that's easy to do. And then if we look at the terminal, first time you open the terminal, it'll run Antidote, which is a Z Shell plugin config, and we can do things like ls the directory, you can ls dash lh the directory and see that things are actually owned by the proper user. Maybe I could tweak the ls colors to be a little bit less gaudy, like .github is a folder, .git's a folder, Devcontainers is a folder. So you might be wondering, like, okay, that's cool. How does this work? Okay, that's the README. It also gives you this warning. This is a bug. Unable to find JDK, that project SDK, on current Docker image. So IntelliJ IDEA is natively a Java IDE. I use it for everything though. It doesn't need an SDK. In fact, I use Python as an SDK, and it's just happy with that. So that's something I'll be filing in the issue tracker. But if we look at our repo, we have a .devcontainer folder. That looks interesting. We have a .github folder. Docs, .files, Envoy schema generator, make libs, make files, and make files. So I'm just going to go ahead and run make help to show you that things do work. So if we run make help, let's make that a little bigger. Available modules. So we have dependencies, JSON schema, poetry, versioning, and Z. So the whole purpose of this particular project is to convert Envoy proxy protocol buffer schema into JSON schema. And I essentially went down a rabbit hole of wanting to do this, but in a reproducible way. And then I learned about Devcontainers, and I went down a rabbit hole in Devcontainers. And then I realized that none of my dev tools were in the Devcontainer, so I stood up a whole dev stack in Devcontainers. So let's take a look at a Devcontainer JSON. It might look hairy at first, but it's actually pretty straightforward to. Come on, let's make that a little bit smaller. It's pretty straightforward to configure. So it has a name, it has an image. So you can either have build or image. When you're first building your dev container, you have a build item, just like you'd have in a Docker Compose file. So you have build, and then you say like the context is dev container, the file is Docker file, and then I give it when I run, I pass your SSH auth socket to the SSH agent in the container, and then I give it a host. I give the container a host name, just because having the host name as the random container ID isn't as fun. Why not have it be the project name, right? Remote user. So in my Docker file that I'll show in a little bit, I have a developer user that has sudo access to do everything else that the root user can do. It's just because the tools that I install, they work better when they're installed as an actual user and not as root. Remote env, so this is what env is going to be set, like what environment variables are going to be set in the container, like injected into the container. So SSH auth socket matches SSH auth socket from our env mount. Our project root, I set it up to be in the developer's home developer source directory, because that's what I do. Even though you saw down here, IntelliJ does force you to keep your projects in IDEA projects, but I made a symlink, so in my command line I can be in my preferred directory for source, and it'll still edit files in this file editor that it has open in IntelliJ. Setup Zeesh, defaulted to false, but I actually ignore this environment variable because I pass in your local shell. So just so happens that I run my local shell on macOS as Zeesh, so If your shell is Z shell, it will pick up the fact that you use Z shell, pass that to the dev container, and set up a Z shell environment for you. If you use bash, it sets up a pretty minimal, but albeit I think it's good, bash shell environment. Mounts, so we mount the SSH auth socket uh, from the host into the container. And now, granted, I'm running this on a remote Docker target, right? So I actually am SSH it's a two-way interaction. So I have SSH auth forwarding from my MacBook to my host, to my DevBox host, which then gets an SSH auth socket. So it's getting the auth socket from my SSH host DevBox and then passing it into the container. And that only happens when I'm logged into the DevBox, which is when I have an IDE session open. Then we have features. So features are a pretty cool thing. They're like plugins for dev containers. So I have Git. It's pretty much just make sure that you have an up-to-date version of Git. They build it from a source for you. There's also a feature that's Docker and Docker, which I'm going to look into exploring. So you could actually use Docker from inside of your dev container Docker image, and you could have isolated namespaces, I believe, and things like that. So for projects like Catalyst or Reagent, we could all be developing in a dev container. All of our dependencies would be the same. Our developer environments would be ostensibly the same, with the ability to customize them if you so choose. And then customizations. I left this in here because I wanted to try it in VS Code. Microsoft is a lot more invested in dev containers, so they have customizations where you can actually choose what extensions VS Code is going to install into your VS Code instance when you launch the dev container. So this has Python, Go, Protocol 3, and the Docker Azure tools for some reason. And then post create command is essentially like an entry point, but it runs after the container has already run the entry point, and after the container has already started. So I run the entry point twice if you see that. So if you look at our Docker file, I go from Rocky Linux just because I figured why not. It was originally from like Debian Bookworm or something, and I just have a preference for enterprise Linux based distros. I was going to go for Fedora, but I realized that all of our other containers for other projects are Rocky Linux or RHEL, so I was like, let's stay within the realm of things that are familiar to myself/people. You can add labels for open containers. This gives container provenance information. And then here's where you get into the fun stuff. So reproducible developer environments. Like we literally install like anything and everything you'd want, but a minimal subset of anything and everything you'd want to be able to develop on this Docker container. So first thing we do is install a bunch of dependencies, like we install Golang, install the ps command, install zshell, install the which command, like so it's not installed by default. I don't know. Just we need that auto jump zshell. That's so you can hit J in the terminal and jump around places. util Linux user gives you the ability to run the change shell command, and the file command tells you what kind of file things are. So we install those. We then run dnf clean all to reduce the image size. We then remove the dnf cache, and we remove the temp to make sure that our images stay small on that layer. Then we add a developer user who is group wheel, so essentially a pseudo user, and then we essentially say that developer all requires no password for everything into sudoers. That way our developer user can effectively be like a root user if we have to be. And that's, you still keep the root user because the tools use the root user when they do things on your behalf. But then we switch into the developer's home directory, and we start doing things that require, or don't require, but that recommend that you have a user created. So we install pyenv and we init it. PyEnv is a Python version manager, for those who don't know. It goes into zshrc, but I actually have this overridden and copied in dot files, so there's a shared shell RC between bash RC and zshrc that makes sure that PyEnv works in both shells no matter which shell you're using. Then we install Python, then we install Poetry, which is a Python package manager. Then we install NVM, which is the node version manager. And then we already had Go installed from DNF, so we go install the specific versions of Go that we need to build our protobuf JSON project, essentially, because libs gets populated with, I don't think it's populated now, is it? No, it's not. Libs gets populated with a bunch of Go projects, so we need to be able to build those. And then we have a commented out file, so I love this command called tree. Like, there's a command called tree that's TREE. Well, TRE or tray is much better. And this is a Rust project. It is having trouble building with the limited amount of RAM and resources that the free GitHub runners give it. So, like, building on x86 for tray, totally fine. Building on ARM, not fine. So, gonna look into that at some point. But then we copy protobuf from the protobuf image. I have a separate image in under images that just builds protobuf, because that takes forever to build protobuf and proto-C. So I was like, I only need to do this once, so we're going to do it once, and then we're going to copy the binaries that I need over. Because for some reason, there's not just like a packaged version of protobuf. You got to do it yourself, so that's cool. And then we set up Git to use the SSH agent, so there's an if check to just see that if there's a key added. That's what SSHL does. Like, let's say if we have any keys, and if we do have keys, then SSH forwarding is good to go. And then we're going to change all of our Git HTTPS URLs from here on out in the Docker file to use the SSH clone URL as opposed to the HTTPS URL, just in case you wanted to clone private Git repos. It's also in my, don't quote me on this, I think it's a little bit faster. And then if you don't have SSH forwarding enabled, let's say you just ran this container to debug it, then it's going to use HTTPS for Git, in which case, if you're using private repos, you'll have to enter in your password and things like that. So then we make an SSH folder, or an SSH directory. We make sure that github.com is in known hosts. And then we copy all of our dot files to the right place. So doing that previous dot file manipulation was kind of irrelevant because I do it manually here. Then we copy the setup script, which I'll go into after I go through this Docker file. We make it executable. We install Antidote before we start Zeesh. And then we set the shell for Z shell, which is kind of redundant. Don't really necessarily need to do that. We set the entry point to be our developer entry point. Then we set the default command to be Z shell. Now let's go look at our developer entry point. So first thing we do is check that if we're in an IDEA project, and I've tried this in Intellij IDEA, and I've tried this in VS Code, and they both work equally as well. So that was cool. But I was like, first off, the setup dev environment.sh runs when runs after the container is created. So like when I hit continue on that gateway prompt, that's when this setup dev environment sh was running. So first of all, in the script, I check if we're in IDEA projects. If we are in IDEA projects, then I'm going to chown all of the folders in the repo under idea projects to developer, because by default, I guess they got lazy or they figured it was just a good idea. They just chmod 777 all the files under the idea projects folder, and that makes you have to do commands with git every time because it's not your user, and it's annoying. So I fixed that. VS Code does not suffer the same problem. VS Code will clone your code to wherever you tell it to, which could, in theory, be like the right place, like home developer, and then like the name of the project. But then again, we shown our dot files, activate and install Antidote if it's not already installed. So let's say you are messing around with your dev container config and you want to rerun setup dev environment. It's kind of I don't know what the word is. It's self-healing, so to say. So even though we already cloned it in the Docker file, let's say you deleted the Antidote folder, or you just need to make sure that you have a somewhat fresh install again, you got that. And then if you want the Z command, we install Zoxide, which also has other tools. I've yet to play around with them, but it works pretty well so far, depending on whether I want to go with J or Z. So yeah, we changed the default shell to Z. So if your shell is not Z shell, then we're going to change your Z shell to Z shell. So we have optionality on shells. If you delete these lines, you can use bash if you want to. And we keep bash in the container because obviously some things want to write bash scripts, and bash is great. And if you really want to use bash, when you log in and you're in a Z shell prompt, you just type bash, and then you get bash. But if you want to be cool, use Z shell. Find executable. This is leftover from doing something else. And then we have some debug information, like who the current user is, what the current directory is, current path, current shell, each location, bash location, and then we essentially just make a mount point for not even a mount point, a mount point for a symlink. So if you're in idea projects, then we're going to make sure that your mount point is somewhere in idea projects, and then we're going to ln-s the idea projects into some sensible home directory location. So when you're using shell scripts, you can write them against this directory or your mount point directory. And if you're using VS Code, it'll be under workspaces. So workspace envoy config. There's a typo. Interesting. So again, and again the project root. Get GitHub username. I thought I was a genius for doing this. So if you have SSH forwarding enabled and you didn't know this, so if you SSH into git@github.com, that's just to check if your SSH key works. So it says hello, username, you're good to go to use GitHub, and then it's like you don't have a login terminal, see ya. So I just used a regular expression and extracted your username and set your username, which was great. And that worked. And then we have a bunch of inner nested if statements to check your get username and set your get username, because if you don't do this, then you have to do git config --global user.name equals, then manually type in your username, and then you have to do git config -global user.email, type in your user email, or you could just grab their username and do @users.noreply.github.com, and that's an alias for everybody's username. So that works, and that makes things automagic, which I like. Then auto setup is a variable that you can set in Devcontainers. Let's say you cloned this locally or something, or in the future if I want people to actually build the project before they get dumped into it, You can run auto setup, and that's pretty much just going to make install deps and make generate JSON schema. So this is what the point of the program, or this is what the point of the repo actually is generate the JSON schema. But I'm going to have a separate container that does these two things. So it's not going to have all these dev container dependencies. It's going to be a really minimal container that runs on a cron job that is in sync with Envoy. So anytime Envoy releases a new version, they're probably, or they might have new protocol buffer definitions. I'm going to go rip those protocol definitions, and I'm going to generate JSON schema. So that way when I'm editing my JSON schema in IntelliJ or VS Code, I can add my releases JSON schema to my editor, and I will get type hinting, and it will correct my JSON schema. So yeah, that's what I wanted to share for Devcontainers, and it's got stuff like you want Python, like great. You want PyEnv, you got PyEnv. You want Node env. I don't even know how to spell Node env. NVM. You want NVM? You got NVM. You want Node version? You got Node, and this is great because it's all of the dependencies required to work on the different parts of this project, which I made unnecessarily large. So there's a docs site, so you need Node to work on the docs site, you need which npm, you gotta have npm installed, or yarn, or pnpm. You obviously have to have Go to run some of the stuff in the make files. You have to have poetry, because the way I do some of our commands for poetry and the automatic versioning detection is in poetry, so it runs Python as a script in CI. And then we have one last thing, actually, our GitHub CI workflows. So the build and push dev container, it's pretty simple. It literally just checks the image out, sets up QEMU, and then runs a build of ARM64 and AMD64 for the dev container project. And then for deploy docs, probably even simpler, checks out the code, sets up Node, even though Node's already set up. But that's how GitHub actions work. You just use these little build blocks, and it does it for you. So we run npm CI, we generate a build bundle, and then we upload it to GitHub Pages. And if you were to go to our project page, we have a pretty default Docusaurus website that will eventually contain instructions as to how to install the JSON schema and how to work on the project. This is a fun little side project, and I figured this would make it a good recorded tech talk, so thank you for watching. See y'all later.